Okay, so what we're going to do today is focus on what to do if you're dividing and there's a decimal in your divisor. In class today, we focused on how to divide with decimals in the dividend. And in order to be able to be successful with decimals in the divisor, you really need to know your stuff when it comes in with decimals in the dividend. So let's really quickly review what to do if you find a decimal in your dividend. Okay, so here it is. What you do is you will bring it right up because the decimal in the dividend has the same exact location as the decimal in the quotient. Okay, so you do that to start. Now your placement, like I say, is extremely important. So 3 should go into 4 one time, bring down the 5. So that 5 is now in the 10th place because of that decimal point. Goes in evenly, bring down the 2. The 3 doesn't go into 2. So, or it goes in 0 times for those of you who prefer to think of it like that. And now here we have our remainder, right? We have 2 remaining. You can refer to that as remainder 2, 2/3, but that's not appropriate in this setting because we have a decimal, and it wouldn't make sense to really have a decimal part and a fraction part. So what we need to do is continue on to represent this remainder as a decimal, and how we do that is we add in zeros, because when we add in this 0 right here, we're not changing the value of 4 and 52/100ths. Now it's just 4 and 520 thousandths. So let's go ahead. We can add as many zeros as we'd like. Let's bring this down. Okay, so now we're back at the top of our steps. Okay, how many times does 3 go into 20? It goes in 6 times, with 2 remaining. Okay, so now I'm going to add another 0, bring it down. Okay, so right off the bat, and I'm sure that you guys noticed, this is the same situation. Okay, so I have a prediction. I'm going to make sure, but I have a prediction that this 6 right here in the thousandths place will end up repeating. Okay, so let's just make sure. How many times does 3 go into 20? Yeah, I was right. It goes in 6 times, and we can continue to subtract, but we'll still be left with that 2, and we'll always be bringing down and getting 20. So the way to express this appropriately would be 1.506 with a repeating sign over it. Okay. So the key, guys, is that you're just continuing to add zeros and bring them down. Okay, until you either get to the thousandths place, until you realize a repeating pattern, or until it terminates. Okay. So what I'd like you to do is go ahead and pause the video and try this problem on your worksheet. What you should get, let's just go ahead really quick. I'll show you what you should get. You should bring up this decimal in the dividend to its same exact place in the divisor. And then let's check it out. 92 and 1600ths divided by 11. You should get 8, and if you went to the thousandths place, you should get this. I didn't want to show you again because I just showed you an example, but just so that you can check your work. And you know, this makes sense because we have 92, about 92 divided by 11. So I would expect my answer to be around 9, and my answer is 8 and then some. So that answer is justified based on my estimation. Okay, so hopefully this is a quick review for you on how to divide with decimals in the dividend. Remember, you just keep bringing those zeros down. Okay, so now let's flip our attention to having decimal points in the divisor. So here's two different ways that you can set up this problem. I'm going to set it up so that we can treat this as a long division problem. Okay, so we have 458 divided by 600ths. And now let's think about this generally. How many times does 600ths, okay, that should be right this much, right? 600ths. How many times would that fit into 458 holes? Well, I'm expecting it to go in quite a lot of times because 600ths is so small. I'm expecting a pretty big number as my answer because there's probably a lot of groups of 600ths to get to 458 holes. Okay, so the first thing that you need to realize is that this problem can be expressed as a fraction, which I've showed you a couple times. Now, the goal of dividing when you have a decimal in your divisor is that you're allowed to make that divisor into a whole number. you can do that, and that's what you need to do before you proceed. That decimal divisor, this right here, this needs to become a whole number before you can go on, okay? So the way that we can do that is by understanding equivalent fractions, okay? So to keep this fraction equivalent, you need to do the same thing to the bottom that you do to the top, okay? To make 6/100ths a whole number, think to yourself what I would have to multiply 6/100ths by to get it to be the whole number 6. Okay, so I'm going to move this decimal place over. Just like this, I'm actually multiplying it just by 10. And so if I go over twice, I'm multiplying by 100. Okay, and then what I get is 6 points, so it's just 6. Okay. Now if I multiply the denominator by 100, then I need to do the exact same thing to the numerator. I need to do the exact same thing to 458. Okay. This is how you keep this equivalent. This is what drives this rule. So let me show you how that would look in the long division problem. So if you are multiplying 6/100ths to get to a point where it's a whole number, like I said, you would multiply by 10, 100, and then sure enough, that's just 6. That's a regular 6. Okay, we have this 0 here. If you want, you can erase that, but you've moved it over twice. You've multiplied by 100. Now the same situation goes for the dividend. Okay, so how would I multiply this by 100? Okay, remember what we talked about, this invisible decimal in the dividend would go right here. I'm not changing the value at all. Okay, so if I multiply the divisor by 100, then I need to multiply the dividend by 100 as well. 10, 100. Now what would go inside here? Well, you guys know zeros would. Okay, now here's my new problem. That's it. And that's equivalent because we've treated the numerator and the denominator the same, okay? Instead of having a 6/100ths on the outside, we've moved it over, the decimal over twice, and it becomes 6. And instead of having 458, after we multiplied by 100, that turned into 45,800. So now what we do is go through the regular steps, and this now should be pretty easy for you. What I want you to do is represent your remainder as a decimal. So what that means is that you need to hike this up before you do anything else. So to go through this, just the regular old way, I'm going to go really fast. 6 goes into 45. Let's see, 7 times. 7 times. Brings you to 42. You have 3 remaining. Bring down the 8. 6 goes into 38. 6 times minus 36. Leaves you with 2. Bring down the 0. 6 goes into 20 3 times. That leaves you 18. You have 2 left. Bring down this 0. 6 goes into 20 3 times. Okay, I'm going to hike this up right here. 3 times 6. 3 times 6 is 18. I'm going to subtract again, leaving me with 2. Now I still have a remainder, and right now I'm not even on my part side yet. This is just my whole number, 7,633. That's my whole number. So I need to keep going at least 3 more places to get an accurate answer. But I can kind of see this pattern forming because each time I bring down that 0, which this would be the next one, I get a 20. And I know that 6 can only go into 20 3 times, and then that brings me to 18, and it'll always be this 20. So I can safely assume this is going to be a 3 repeating. Okay, so our answer is 7,633, sorry, slowing down on me, with a 3 repeating. And that fits the mold of my prediction, where I have 6/10, this small bitty fraction, and it would take 7,633 of these to create 458 wholes, which makes sense because that's a very small amount. Okay, let's do one more together. This one has a decimal in both the divisor and the dividend, but really there's really no difference. Okay, so if you set it up 34 and 4/10 and then just a 2/10 on the outside, the same thing applies. We have to treat the numerator and the denominator the same. What would it take to multiply this 2/10 by to get it to be a whole 2? Well, we would just multiply it by 10. Okay, it's just that 1/10, and now we can treat it just like a 2. Okay, so if you did that to your denominator, then you need to do the exact same thing to your numerator, because then, this is a 1 I'm drawing around it, by the way, your value is preserved. 10 over 10 is 1. Okay, so I multiplied 2/10 by 10, so I need to go over in the dividend and do the same thing. Okay, I preserved the value here. I haven't changed the value at all because I'm treating them alike. So now basically, guys, it's just like this. This became a 2 when we multiplied by 10, and this became 344 when we multiplied by 10. Now you go through the same motions as always, making sure to express your remainder as a decimal. It goes in 1 time, 7 times, 2 times. Oh, we don't have a remainder. We just have 172 wholes. Okay, so the answer to this problem would be 172. And again, that makes sense because we're originally asking how many 2/10, very small. Right, it's just this area right here. How many 2/10 can fit into, let's see, 34, about 34 holes. Now it's only 2/10. You need 5 groups of 2/10 to just get 1. Now you need to get to 34, so you would expect your answer to be quite big. You need a lot of groups of 2/10 to get to 34 holes. Okay, so it's just, guys, it's really what it comes down to is just this movement of the decimal place and this balance when you're moving the decimal place. Okay, so I'm going to put a couple, just going to put 2, and I want you to try these 2 using the video. If you're not sure, look back. Okay, so I'm going to give you a try. Okay, let's see. Let's have our dividend will be a whole number, and our divisor will be a decimal, 2/200ths. Oh boy, that should fit in a whole lot of times. 2/10 into 403 holes. And in this one, we'll have our dividend have a decimal point, and our divisor as well. We'll do that. Okay. Now remember, it's all about the movement of that decimal point and balancing it out. But that's as much of a hint as I'm going to give you. Okay? Hopefully we've accomplished our objective. Remember to look back when you're trying your problems.